Maths Aspirants is a collective of mathematics students, research scholars and faculty members across India, initiated by myself in 2017. And we used to organize several programs to help the students who are preparing for different national level competitive examinations in higher mathematics. As a part of that online problem solving session series, today we are having Ms. Shahana Kappil. She is currently pursuing PhD at Khalifa University, UAE. So I am very happy to introduce Ms. Shahana to you. Shahana is from Kerala, and she did her MSc from MES Mambad College, Malappuram, and she qualified CSE NET. So I'm very happy and proud to introduce Ms. Shahana. And also I would like to express my sincere gratitude to her for being with us. I welcome everyone to today's program. Today we are planning a problem solving session focusing on linear algebra. So it's a very important topic for any competitive examination. So I'm sure that today's session will be certainly helpful in your final round preparations. So welcome everyone to this program. Welcome, Shahana.
Thank you so much, Doctor. First of all, thank you everyone for joining the session. And I'm really grateful for Dr. Vinod sir, as he has organized such math experience group. This is really helpful for all the competitive exams. And thank you for inviting me to Doctor. So I think let's start the session. So mainly here, I have chosen some of the problems from the linear algebra, which have previously appeared in the IIT JAM exams. So I hope everyone has a basic idea about some of the concepts that's really required in the linear algebra, like the rank, nullity, vector space, subspace, the dimension, eigenvalues, such things. So I'm just gonna start the presentation now. So I think we can just start with some simple problems. Okay. So this one has appeared in previous IIT JAM exam in 2022. Okay. So in this problem, let's consider a 2 by 2 matrix, and the matrix M is given as 1, 1, 1, 0. And if the 8th power of M satisfies M to the power of 8 times 1, 0, the column vector is equal to xy. Then you need to find the value of x. Okay, so here we have the matrix M, which is equal to 1, 1, 1, 0. Okay, and we need to find M to the power of 8. You know 8 is 2 cubed, so definitely we can write this as M square, whole square, and the whole square, right? So how can we proceed with the calculation? First, we need to find M square, then M to the power of 4, then we can find M to the power of 8. Okay, so the M square will be as equal to 1, 1, 1, sorry, 1, 1, 1, 0 times 1, 1, 1, 0. Okay, this will be equal to 2, 1, and 1, then 1. Okay, this will be our M square. Now, M square, the whole square, okay, which will be M to the power of 4, which is equal to 2, 1, 1, 1 times 2, 1, 1, 1. Okay, then from here we will get 4 plus 1, it is 5, then we will get 3, then here 3, then 2. Okay, then the last one, that is, we have M to the power of 4 here, right? So M to the power of 4 whole square, which is M to the power of 8, that's what we need. So this is 5, 3, 3, 2 times 5, 3, 3, 2. Okay, which you will get It's 34, then it's 21, then 21. Definitely this will be a symmetric matrix, correct? Then it will be 21, then 9 plus 4, it will be 13, okay? So what we need to find is m to the power of 8 times 1, 0, right? So we have m to the power of 8 with s, then m to the power of 8 times 1, 0, matrix will be equals 34, 21, 21, 13 times 1, 0, which will be equals 34, 21. So the question is, we need to find the value of x. So this will be the value of x. Okay. So the third option will be the correct answer. Anyway, this will be an easy one, but the idea is mainly how to find the m to the power of 8. Okay. The way you are finding m to the power of 8. So the answer is option C. Okay. So moving to the second question. This question appeared in the recent IIT JAM exam, so it's in 2023. Okay. And here the question is, we have two non-empty subsets of R2, S and T. They didn't specifically mention which one is the subset. So, and also the W be a non-zero proper subspace of R2. You need to be careful. It is non-zero and this is a proper subspace of R2. So if W is a proper subspace of R2, what all can be the possibilities for the dimension of W? Dimension of W, in total it have possibilities like 0, 1, 2. But it's mentioned it is a non-zero. So its dimension is not going to be 0. And it's a proper subspace, which means the W will not be equal to R2. So the 2 is not also possible. So the only possibility is dimension of W as 1. So we can just arbitrarily choose W, which is equal to the set of all x, x, where x is a real number. Okay. So if this is our R2 space, the W I'm choosing like the y equal to x-axis. Y equal to x-axis will be the W. Okay. So what does this mean? How can we write this y equal to x-axis in the form of span? Span of 1, 1, right? So W is the span of 1, 1. Now let's see. S and T be non-empty subsets of R2 also. Now let's move on to the options. And if in order to prove any statement, you have to look for each and every conditions that it should satisfy for all the cases. But in order to prove any statement is false, we need just one counterexample. So we are just looking for such one counterexample in order to show this is false. Okay. So let's see. If span of S is R2, the span of S intersection W is equal to W. Okay. So if span of S is R2, which means, let's see, S will be equal to the set 1, 0, 0, 1. Okay. The span of this S will be R2, no? You know what does it mean by span? Span will be the linear combinations of these elements, okay, or the set of all linear combinations. So what will be the linear combination of 1, 0 and 0, 1 be? It will give the entire R2, right? Okay, so the S is 1, 0, 0, 1. Then what will be the span of S? Span of S will be R2. Okay, good. So the span of S is R2. Now the question is, whether we need to check this S intersection W spans to get W or not. So what will be the S intersection W? This is our S and this is our W. What will be the S intersection W? We can't see any common elements, right? Because this one consists of only 1, 0 and 0, 1. And this one consists of this, the 1 0 is here and 0 1 is here, and the W consists of this line. There is no anything in common. So the S intersection W should be just the null space, phi, correct? But we need to find the span of S intersection W. What will be the span of S intersection W? What is span of phi? Span of phi will be set 0. Okay. So both of us are equal or not? Let's see. Here the span of S intersection W is simply the set 0, but the W is the entire y equal to x-axis. So both are not equal, which means the first statement is not correct. Okay. Now moving on to the second statement, span of S union T. Here one more set is coming, that is T. So let's see. Here we can choose S like the set 1 0, T like set 0 1. Okay. Now span of S will be what? Span of S will be span of 1 0. What is span of 1 0? Span of 1 0 means only this x coordinates will change, right? Like the linear combination of this set 1 0 will be like all the points here, which means the entire x-axis. Correct? What about the span of TB? Span of T will be equal to span of 0 1. Okay, that is the first coordinate will be 0, it's a constant. Only the second coordinates changes. It will changes throughout. So it will be the entire y-axis. Okay. So we got the span S, span T. Now let's see whether the statement is right or not. So what will be the S union T? Because we need to check what is the span of S union T. S union T will be nothing else, the set 1 0, 0 1. Right? Just these two elements together. Then what is span of S union T be? The span of S union T will be the span of this set 1 0 0 1. Okay. Span of 1 0 0 1 means the entire R2, right? This entire R2 will be the span of 1 0 0 1. Okay, just like here the span of S we chose R2, no? So this will be the entire two-dimensional space R2. Okay, then now what is span S union span T? Span S is the x-axis, that is this one. The span T is the y-axis, that is this one. So the span of S union span of T will be just the x-axis and the y-axis. Only these two axes. No other elements are involved. But here it is the entire R2. Right? This is just the x-axis and the y-axis. So are they equal? Span of S union T is not going to be equal with span S union span T because it is only x-axis and y-axis, but this one includes all the points here also, right? So both are not equal. So the second statement is also false. So out of this option, the only correct option is both 1 and 2 are false. Okay, so this is the correct option. Okay. So always if you are asking like these kinds of question, rather than proving with the definition or something, it's better to go with the graph and make your own examples. Okay. Now we need to find the rank of a 4 by 6 matrix. A 4 by 6 matrix is given here. All the real numbers, that is all 0 and 1 are the entries here, and we need to find the rank. Okay. So how can we usually find the rank? If there is a matrix, you can just operate it with some elementary transformations And then after the elementary transformations, just check the number of non-zero pivots. Okay, then you will get the rank. The number of non-zero pivots will be equal to the rank of that matrix. So here I'm just going to apply the row transformation. So this is our matrix 1 1 1 0 0 0 1 0 0 1 1 0 0 1 0 1 0 1 0 0 1 and 0 1 1. Okay, good. Now let's see. We need to make it like an upper triangular matrix, right? So I'm just get rid of this one first. So what can I do here? I just want to subtract the first row from the second row. So I'm just operating on R2 to give R2 minus R1. So the first row will be same as it is, 0, 0, 0. The second row, 1 minus 1 will be 0, minus 1, minus 1, 1, 1, and 0. And all other elements will be the same. 0, 1, 0, 0, 1, 0, 1, 1. Right. Now, what's the next option? I think we can just remove this one here, right? We are just looking for this, for the upper triangular, no? So just get rid of this one. What can we do? So simply just add the second row with the third row. So R3 gives R3 plus R2. Okay. So the first row and second row will be the same. 0 minus 1 minus 1, 1, 1, 0. And here just add together. It will be 0, then minus 1, 2, 1, 1, 0, 0, 1, 0, 1, 1. Okay. Now what? Now look like this. I think we need to just remove this one, right? So what we have to do, just writing here, we need to add the third row and the fourth row, correct? So it will be 1, 1, 1, 0, 0, 0, 0, minus 1, minus 1, 1, 1, 0, 0, 0, minus 1, 2, 1, 1. And then what happened to the fourth row? We just have to add with the third row. It will be 0, 0, then 1 minus 1 to 0, 0, then 2, then here 2, then 2. Clear? Now check. Can we do something else? No, I think this is the last form of this matrix, right? So now see what is the number of non-zero pivots. This one is a pivot, this is a pivot, the pivot, and this one. So there are 4 non-zero pivots. Or else you can check the number of rows with non-zero entries. There are 4 rows with non-zero entries, so the rank should be 4. So this is the correct option. Okay, good. Now, okay, let's look for the another problem, that is, let T from R2 to R2 be the linear transformation. So T is defined from R2 to R2 and it's a linear transformation, and it's given like this. T of xy is equal to minus xy. Okay. And the thing is, if you are given with any of the linear transformation, I would suggest you to find the corresponding matrix for that linear transformation. Then you can just work on that matrix in order to find the rank, nullity, whatever. Okay. So here you have given with the linear transformation. Then how can you find the corresponding matrix of a linear transformation? The thing is, if you are provided with any of the bases, just work on that basis. No, or else here the basis is not mentioned, so it's better to go with the standard basis. Okay, the standard basis of R2. What is the standard basis of R2? The standard basis of R2 is the set 1 0 0 1, right? What about R3? It will be 1 0 0 0 1 0 0 0 1. Okay. So as it is R2, there will be 2 elements. Okay. Now let's work on this basis. So what will be the T of 1, 0? T of the first standard basis. First element in standard basis. What is T of 1, 0 will be? It will be minus 1, 0, right? Just substitute in this, then you will get minus 1, 0. What about the next one? T of 0, 1. T of 0, 1 will be 0, 1, right? And this can be written as the linear combination of the standard basis, like minus 1 times 1, 0 plus 0 times 0, 1, which is equal to, here is equal to 0 times 1, 0 plus 1 times 0, 1. Clear? Now we can write these coefficients of each elements in a column form. Then you will get the corresponding matrix for the linear transformation. So here the matrix for the T will be equal to minus 1 and 0. See, this one minus 1, 0. Write it as a column, and here 0, 1. Okay. So this is the matrix for the T. Now, if you have a matrix, can you find the corresponding polynomial here? What will be the polynomial of this matrix? If it is a 2 by 2 matrix, just go with x square minus trace times trace of this matrix, okay, times x plus determinant of the matrix. Okay. So here x square minus, what is the trace of this matrix? Trace means the sum of the diagonal entries. That is minus 1 plus 1 is a 0. So 0 times x plus, what is the determinant here? Simply minus 1, which is equal to 0. Okay. So x square minus 1 equal to 0 is the corresponding polynomial for the matrix. So the first step, if you are done with the linear transformation, is just write the standard basis of R2, then work on the standard basis to get the matrix representation. And now we have the matrix representation, then now write the corresponding polynomial of this. Now we got this, right? So this is the corresponding polynomial of the matrix T, which means the matrix T can also satisfy this equation, right? So how can you write this? T square minus, instead of 1, it's an identity matrix equal to 0. You can write like this. That means T square is equal to identity. Correct? This is what we need. Now we can look to the options. Now you can look to the options based on this formula. Good. So T square is equal to I. That's what we have. Look for the first option. T to the power 2k is equal to T for all k greater than or equal to 1. For all k, which means it should satisfy for everything. So first I'm just choosing k is equal to 1. What happens if k is equal to 1? Let's look for the option A. If k is equal to 1, T to the power of 2 times 1, that is T to the power of 2, is equal to T. Look, is that same? No. T to the power of 2 need to be I, correct? So here it is T, which means the first option is not true. Okay, so here the T square we got T, but according to the linear transformation, T square should be identity. Okay, so this one is wrong. And now look for the option B, the same. Let's give k is equal to 1 here. What will be the answer? T 2 times 1 plus 1 is equal to minus T, which implies T to the power 2 plus 1 T cube is equal to minus T. But here what will be the T cube? The T cube means just multiply both sides with the T, should be simply T. But according to the option, it is minus T. Both are not same, which means the option B is also not correct. Okay. Yeah. Now this third and the fourth option, it's something related to the range, right? Now let's look for what will be the range of the t square, everything. Okay. Here we got the t as -1, 0, 0, 1, right? Which means what will be the rank of t? The rank of t will be number of non-zero rows, right? It is 2. Correct? Then what about the rank of t square? T square is equal to identity. There is a 2 by 2 identity. So the rank of t square will also be equal to 2. We have these two things. Rank of t 2, rank of t square 2. Now just relate with the options. Okay. Here the rank of t is 2, which means it will be isomorphic to our R2, this R2. Correct? Because the t is a mapping from R2 to R2. So, and it's a range will contains the entire R2, right? Because the rank of t is R2, so the range will contains the entire R2. So the range space of t will be what? Range of t will be the entire R2. How I got its R2? Just look for the rank of t is 2 and it is defined from R2 to R2. So definitely the range space will be the entire R2. Similarly, for the t square, what happens? The rank of t square is 2 and the t square will also be defined from R2 to R2, right? Because t is from R2 to R2, then t square will also be from R2 to R2. And then the range space of t square will contains only the entire R2. So the range of t square will also be is equal to the entire R2, which means the range of t and the range of t square are equal. These two will be equal. So which option says that both are equal? The range of t square is equal to the range of t. So option D is correct. Okay. What about option C? Is that correct? The range of t square is a proper subspace of range of t. No, it's not a proper subspace. They are equal, which means the C is not correct. Okay. So always just look for the options and then see what we can do from the statement. Okay. So option D is the answer. So the next question is, okay, it's also related to linear transformation. So the statement says for an integer k greater than or equal to 0, let pk denote the vector space of all real polynomials in one variable of degree less than or equal to k. Okay. So what does pk means? Pk means the set of all real polynomials whose degree is less than or equal to k. Then define a linear transformation T from P2 to P3 by T f of x is equal to f double dash of x plus x f of x. So from where the T is defined? From P2 to P3, right? So what does this P2 means? The P2 means the set of all polynomials whose degree is less than or equal to 2. That is its basis will be 1x x squared, right? This will be the x square. That is, the P2 contains the polynomials of the form a0 plus a1x plus a2x squared. And so the basis will be 1x x squared, right? Then the linear transformation is given here. So now if this is the basis, let's see what will be the T of f of x. So just like the previous problem, in the previous problem we worked on the standard basis. Right. So here also I'm just working with the standard basis. I'm taking each elements from the standard basis. Then I'm operating this linear transformation in each elements. Then I'm just looking what is going to happen. Okay. So what will be T of 1? 1 is the first element in the standard basis. It will be f double dash of 1 plus x times f of 1. Right? So what is f double dash of 1? It is 0 plus x, right? F of 1 is 1, so the answer will be x. Similarly, let's look for the second element in the standard basis. What is t of x? The t of x will be equal to f double dash of x plus x times then our f of x. F double dash of x means x 0. F dash of x is 1, then f double dash is 0. So this is 0 plus x. What is our f of x here? It is none other than our x. So here it will be x squared. Good. Now, what is t of x squared? The last element in our standard basis. F double dash of x will be 2 plus x f of x square, that is x square. 2 plus x cube, right? So we got what will be the t of 1, t of x and t of x square, which means the range space of this t should be generated by x, x square and 2 plus x cube, correct? So that is the range space of x should be the t of f of x should be generated by 1 3 x square, then 2 plus x cube, these three. Now let's see whether the question is which of the following polynomials is not in the range of t. So the thing is whether you need to check for each elements is in the range of t or not. So this whatever the answer is, it will be the linear combination of these three, x square and 2 plus x cube. So just check whether you will get these options once we are trying with the linear combination of these elements. So can we get x plus x squared if we try with the linear combination of this one? How can you write? X plus x squared can be written as 1 times this x plus 1 times x squared, correct? So we can generate by using this one, and 0 times 2 plus x cube, right? Plus 0 times 2 plus x cube. So we can generate x plus x squared by using this range space, right? And what about this b? X squared plus x cube plus 2. X squared can be written as 1 times x squared plus, and this 2 plus x cube is 1 times 2 plus x cube. See, again we can just make this polynomial using our generating set. Now what about the c? It's also possible. Just 1 times x plus 1 times 2 plus x cube. So just put the coefficient of x squared as 0, then you can just make this polynomial. Then what about this d? Is it possible for this one x plus 1? No, for x plus 1, see, we don't have any constants here, like 1 is not here, right? So it is not possible to generate x plus 1 using this one. By trying with any of the linear combinations, we won't get this x plus 1 from this, right? So this one will not be in the range of t. So the question is, which of the following polynomials is not this one, not in the range of t, which is this option D is not in the range of t. So this will be the only correct option. Okay, all others are existing in the range of t. So this is the correct option. Now, okay. Now this question is related to the eigenvalues of the matrix. Okay. So here in MBA real 6 by 6 matrix, and like 2 and minus 1 be two eigenvalues of M, 2 and minus 1. So the lambda 1 is 2, lambda 2 is minus 1, eigenvalues of M. And the equation for corresponding to the matrix M is given, M to the power of I is equal to AI plus BM, where A, B are some real numbers. Then the question is, you just have to find the values of A and B, okay? A and B you need to find. So what will be the first step? The only thing that you have is this equation and then the eigenvalues. Okay, so from this equation, you can just write, just bring everything to the left side, I can write n to the power of 5 minus ai minus bm is equal to 0. And I told you if you have a matrix, you can just write the corresponding polynomial here. So it will be x to the power of 5 minus ai, that is the constant a, minus b, x is equal to 0. Just write this equation from the matrix form. Okay. So this one I have. Then what I have? The lambda 1 and lambda 2. And you know, if this is the polynomial, and definitely this eigenvalues will satisfy the equation corresponding to its matrix. Whatever the equation is, it will satisfy. Which means if you substitute lambda 1 equal to 2, it will satisfy. Also if lambda 2 equal to minus 1, this one will satisfy. So I'm giving lambda 1 is equal to 2. So then what will be this one? It will be 2 to the power of 5 minus a minus b and x is 2, right? It's equal to sum 0. Yeah, equal to 0. 2 to the power of 5 is 32 minus a minus 2b is equal to 0. This is the equation that I have. Just put it as equation number 1. And then I have another lambda, that is lambda 2 is equal to minus 1. The equation will satisfy this one as well. So the minus 1 to the power of 5 minus a minus b times minus 1, which is equal to 0. So what is minus 10 to the power of 5? This is simply minus 1 minus a plus b, which is equal to 0. Just put it as equation number 2. So we have two sets of equation and we have two unknowns, a and b. Now let's solve this one and 2. How can you solve this? Just the equation number 1 minus equation number 2, I will get 32 minus 1, it should be 33, minus a plus a will be 0, and minus 2b minus b, so minus 3b, which is equal to 0, right? Which implies 33 is equal to 3b, b is equal to 33 divided by 3, that is 11. B is 11. B is 11, which means option B is not correct. Option D is not correct. So the answer will be A or C. So for that, let's see what will be the value of A. So I think you can just substitute in either 1 or 2. I think 2 is, sorry. I think equation number 2 is just easy for substituting. So it will be minus 1 minus a plus b. What is b? It is 11. It's equal to 0, which will be minus a plus 10 equal to 0. A will be equal to 10. Okay. So the a is 10, b is 11. So option A is correct. Okay. So if you are given with these kind of problems, just make an equation out of the matrix form. Okay. So from this, I just made a polynomial. Good. Now, okay. Okay. Now we have another problem. So here n, b, and n by n matrix. So n is greater than or equal to 2, where non-zero real. Always just consider or always just underline these kind of things that you got from the question, okay? Because it is very crucial sometimes. With m square is equal to 0, and let alpha be a non-zero real number, okay? Alpha is non-zero real number. Then alpha is the only eigenvalue of m plus alpha I and m minus alpha I. So we need to find the eigenvalue of m plus alpha I, m minus alpha I, that's that. So first you need to find the eigenvalue of m, then it's easy to work with its polynomial, correct? So we have m square is equal to 0. Okay, if m square is equal to 0, then what will be the corresponding polynomial for the matrix? It will be x square equal to 0. So what is the only possible root of this one? It is 0. X can be 0 only, right? Now, which means the eigenvalue of m will be 0. So the eigenvalue of capital M will be 0. Okay. Now the question is, alpha is the only eigenvalue of M plus alpha I. You know, if lambda is an eigenvalue of any matrix A, then P of lambda will be an eigenvalue of P of A, where P of A is the polynomial corresponding to it. That is, lambda square will be the eigenvalue of A square, like that. Okay. So similarly here, M plus alpha I is a polynomial generated from the matrix M. So if alpha is the eigenvalue of M, alpha is the eigenvalue of M, then what will be the eigenvalue of M plus alpha I? Sorry, if 0 is the eigenvalue of M, what will be the eigenvalue of M plus alpha I? It will be, just substitute instead of M, its eigenvalue, 0 plus alpha, which is equal to alpha. Okay, so alpha will be the eigenvalue of M plus alpha I. Now look for another matrix. This is M minus alpha I. Who will be the eigenvalue of M minus alpha I? Eigenvalue of M is 0, we have from here. Then 0 minus alpha. That is, minus alpha will be the eigenvalue of M minus alpha I. Got it? So in the option A, is it correct? No. Here alpha is the only eigenvalue of both the matrix. It's wrong. The eigenvalue of this one will be alpha. The eigenvalue of this one will be minus alpha. Clear? So option A is wrong. Now let's see option B. Says alpha is the only eigenvalue of M plus alpha I and alpha I minus M. So this one we have, it's alpha from here. What is alpha I minus M? For the alpha I minus M, its only eigenvalue will be alpha minus the eigenvalue of M, it is 0. That is alpha. So the alpha will be the eigenvalue of this one as well. Yes, so option B is correct. Alpha is the only eigenvalue of M plus alpha I and alpha I minus M. Now we don't need to find any eigenvalues further, because here M plus alpha is eigenvalues minus alpha. No, it's wrong. Then M plus alpha I, its eigenvalues minus alpha. It's not correct because alpha is the eigenvalue here. So the only correct option is option B, right? So this is the only possible option. Now let's see. Okay, so now let's look for the next problem. Yeah. Here, the set of eigenvalues of which one of the following matrices is not equal to the set of eigenvalues of 1, 2, 4, 3. Okay. So here, actually you don't need to find the eigenvalue of this matrix. There are some properties, no? So you can just work with that. So, let's see. 1, 2, 4, 3 is the matrix. And what is the, always what will be the eigenvalues of a matrix? Okay, so let's see. Here the corresponding characteristic polynomial will be x square CAF CA of x is equal to, characteristic polynomial of a 2 by 2 matrix will be x square minus trace of the matrix. Suppose this is a matrix A. Trace of the matrix A times x plus determinant of the matrix A. Right? This is the characteristic polynomial, correct? And the root of this characteristic polynomial will be the eigenvalue, correct? So the trace of A, here the trace will be 1 plus 3. It is 4, correct? And the determinant of A, it will be just 3 minus 8, 3 minus 8, which is equal to minus 5 is the determinant. Okay. So the trace and determinant we have. Then just check whether the trace and determinant for these metrics are the same or not. If they have the same trace and determinant, which means they also have the same set of eigenvalues, correct? So here, what will be the trace? When we are comparing this matrix with this matrix in the question, the only change is the anti-diagonal entries are just switched their position, right? Instead of 2, it's 4. Instead of 4, it's 2, like that. Just switch its position. So will it make any difference for the trace? No, trace will be still 4. Or will it make any difference for the determinant? No, it's not going to make any difference for the determinant. It will be still 3 minus 8, correct? So the question is, which of the following matrix is not equal? So this one should have the same eigenvalue like this one. The problem is not equal. Okay, so this one is not the correct one. And now let's look for the option number B. So here, what is the difference from our reference matrix? Here, the diagonal entries are just switched their positions. The diagonal entries, correct? Instead of 1 and 3, it's just switched their position. Which means the trace is different. No, the trace is not going to be changed. The determinant is also not going to be changed. Which means it also had the same eigenvalues like before, which means this is not the answer. Now let's check option C. Here, the both of them have changed the position. The diagonal entries, see 1 and 3, just change it, and the anti-diagonal entries are also just changed. Still, the trace will be 4 and the determinant will be minus 5. So eigenvalue is not going to change. So this is not the option. So the only option will be D. Or if you want, you can just calculate and just confirm for yourself. Here the trace changed. What is it? 2 plus 4. The trace becomes 6. But no problem. It will be 4. Okay. So this one is. So this option D will be the answer. Okay, clear? So rather than wasting your time for finding the eigenvalue by solving the whole equation, you just have to know about some of the properties. Okay. So the next problem, let S and T be linear transformations. 2 transformations. Okay, before we discussed about 1 transformation. Now there are 2 transformations. And from a finite dimensional vector space V to itself, such that S of T of V is equal to 0 for all V belongs to V. Okay, so here this, okay, we have this S of T of V is equal to 0. And see, this vector space have the dimension, finite dimension. So let's assume the dimension of V is equal to some finite number n. Okay. Now, S of T of V is equal to 0. What does that mean by this? What does the T of V means? Here the S is defined from V to V. S is a linear transformation from V to itself. T is also a linear transformation from V to itself. Right? Now let's see what is T of V means. T of V means the range space of T. Correct? So S of range space of T is equal to 0. So T of V is the range of T and S of range of T is equal to 0. That's what we have. Now we need to show these inequalities, correct? So S of range of T equal to 0 means where this range of T belongs to. It belongs to the null space of S, correct? What does it mean by null space? Well, what is the definition of null space of S? Null space of S is equal to all the set of all X belongs to S such that S of X is equal to 0. Correct? Like that. So it will be all the elements where it will maps to only the 0. Right. So this range of T is an element where this S maps this range of T to 0. That means this range of T will be in the null space of S. Correct? It will be in the null space of S as per the definition. Range of T is in the null space of S means its dimension will be less than or equal to its dimension. correct? So dimension of range of T is going to be less than or equal to dimension of null space of S. So what is the dimension of the range of T? Means it is rank of T, correct? It is the rank of T, less than or equal to. What is the dimension of null space? Means nullity of S. So the rank of T is less than or equal to nullity of S. And look, do we have such an option? Rank of T is less than or equal to nullity of S, which means option C is correct. And this is a multiple choice question. So let's look for any other option is correct or not. So for that, I'm just taking this inequality and I'm just multiplying this entire inequality with negative. Multiply using minus, okay? What you will get? Minus of rank T. This inequality is going to be change. Then minus of nullity of S. This one I have. Now I'm going to add dimension of V. Dimension of V. Okay, this V. So dimension of V I'm adding on the both sides of this one. I'm getting dimension of V minus rank T is greater than or equal to. I'm adding dimension of V here as well. So it will be dimension of V minus nullity of S. What is dimension minus rank? Dimension of V minus rank as per the rank nullity theorem. Rank nullity theorem. Rank nullity theorem. The dimension of V should be equal to nullity plus rank. Correct? So as per the rank nullity theorem, I can write this dimension of V minus rank of T is equal to nullity of T. And here it's greater than or equal to, what is dimension of V minus nullity of S? It will be rank of S. Correct? It will be rank. So this is the another inequality that I have. So nullity of T greater than or equal to rank. Nullity of T greater than or equal to rank. C. So the only options will be C and D. Okay, so these are the correct answers. So, okay. Now let's look for the another problem. Okay. So let M and N be any two 4x4 matrices and 4x4 matrices with integer entries. Always they will give us some clues in the statement. So it's better just underline it. Integer entries satisfying M and the product of the matrix is given like this 2 times this matrix. And the question is, there is no any choices, so you just have to write an answer here. Okay, a numerical value. Then the maximum value of determinant of M plus determinant of N is dash. So here we have Mn. So we can just further write this Mn like we need to multiply each and every entries with the 2. So it is going to be like 2, 0, 0, 2, 0, 2, 2, 0, 0, 0, 2, 0, 0, 0, 0, 2. This is our matrix Mn. Okay, now let's find the determinant of Mn. How can we find the determinant of Mn here? Here, I think we can just consider this as another matrix and see here if we are multiplied by using this element, then find the determinant of this and you can just write like Mn is equal to 2 times the determinant of the matrix 2, 2, 0, 0, 2, 0, 0, 0, 2. And then what about these? All other elements are 0 here, right? So we don't need to calculate them. So we just have to consider only this one. And what about here? It will be 2 times these two I'm considering, okay? Then 4, correct? And I will get, it's 16, correct? So this is the determinant of the matrix Mn. But we need to work with the determinant of M and N. So if the determinant of Mn is equal to 16, what information can you get from here? We have from the question, M and N have only integer entries. If M and N have only integer entries, their determinant will also be an integer, right? So the determinant of M and determinant of N is also an integer. So also determinant of Mn can be further split into determinant of M times determinant of N, right? This is equal to this one. And now this one is equal to 16 we have, and also we have the determinant of M and N are integers. So what will be the integer combinations that we get the answer like 16? What will be the possibilities? The determinant of M can be 1. So 1 times 16 will give you 16. Or another possibility is 2 times 8 can give you 16. Or the other possibility is 4 times 4 will give you 16. These are the only possibilities for the determinant M and determinant N, right? And the question is, you need to find the maximum value of determinant M plus determinant of N. So this one, on adding these two determinants, you will get 17. On adding this, you will get 10. On adding this 4 and 4, you will get 8. So the maximum value is 17. So 17 is the answer. Okay. So that's why I told you this information is important. Otherwise, we can't just think about this concept. Okay. So next problem is, let M be a 3 by 3 matrix with real entries. So here is the M with a 3 by 3 matrix with a real entries such that M square is equal to M plus 2I. Okay, where I denotes the 3 by 3 identity matrix if alpha, beta, gamma are eigenvalues of M such that the product of eigenvalues will be the -4, then you need to find what will be the sum of the eigenvalues. Okay, so let's look what information we have. We have M square equal to M plus 2I. Equal to M plus 2I, right? And you remember that in the previous problem, we just find the corresponding polynomial of these kinds of equations. So we are just taking everything in the right side to the left side. -2I is equal to 0. And the corresponding polynomial will be x square minus x minus 2 is equal to 0. Okay, this one we have. Okay, and also, so by how can we just factorize this one, like x plus minus 1 x, sorry, yeah, minus 2, okay, which will be equal to 0. So this will be the corresponding polynomial for the matrix that we have here. Now if we have a equation like this, what is the minimum polynomial? We can find the minimum polynomial. The minimum polynomial is a polynomial which contains all the eigenvalues, but it will not consider how much times the eigenvalues get repeated, right? So what are the possibilities for the minimum polynomial here? It will be, the minimum polynomial will always divide this polynomial, right? X plus 1, x minus 2. So what are the possibilities for the minimum polynomial? Will be x plus 1 is a possibility, or x minus 2 is a possibility, or x plus 1 times x minus 2. These are the three possibilities for the minimum polynomials. Okay. Now let's see which one is the correct minimum polynomial out of this. Is this one will be the minimum polynomial? It's not possible, because when we solve this x plus 1, you will get x equal to minus 1, right? But if you multiply minus 1 a number of times, can you get the minus 4? The product of the eigenvalue should be minus 4. No, you will not get. So this will not be the minimum polynomial we are looking for. And what about here? Here the x is equal to 2 is the solution. So if 2 is the eigenvalue, if you multiply this one, can you get 2 for the 3 times? Can you get minus 4? No, you won't get. So this is not the minimum polynomial. And then the possibility is this, that is x should be minus 1 or x is 2. These are the possibilities. Correct? Now check, can you get minus 4 from here? Multiplying, yes. How can you get minus 1 times 2 times 2? So this eigenvalue will repeat 2 times, and minus 1. So this will be the eigenvalue. On multiplying, you will get minus 4. So this one will get satisfied. Then what is the question here? We need to sum up all the eigenvalues. So here the lambda 1 should be minus 1, lambda 2 should be 2, lambda 3 should be also 2, and we need to sum up them together to get 2 plus 2 minus 1 equal to 3. So 3 will be the answer. Okay. So 3 will be the sum of the eigenvalues B. So that's it. So if you get a polynomial, just write the corresponding function, then just write the minimum polynomial and check which will be the possible minimum polynomial in order to find out the eigenvalues, then work on that eigenvalues. Okay. Yeah. Now there is another problem with the linear transformation. So let T is from R7 to R7 be a linear transformation with nullity of T is equal to 2. Okay. Then the minimum possible value of rank of T square. Nullity of T is given. If nullity of T is given, it's easy to find the rank of T, right? Just by using the rank nullity theorem. But they asked about the rank of T square, not the rank of T. How can we proceed? Here, there is a standard inequality. Rank of product of any two matrices, suppose A and B are any two matrices, the rank of their product should be less than or equal to a minimum of rank of A, comma, rank of B. This will be the upper bound, and its lower bound gonna be rank of A plus rank of B minus n. Okay, so this is the inequality that's going to help us for solving this problem. So this one is really important. Okay, now the rank of T square. T square means T times T. So what will be the rank of T times T? It will be minimum of rank of T, comma, rank of T, and the lower bound will be rank of T plus rank of T minus n. Can you find the rank of T? Yeah, here. What will be the rank of T? Rank of T will be the dimension of this R7 by rank nullity theorem. Okay, by rank nullity theorem, this dimension of R7 minus nullity, right? What is dimension of R7? It will be 7 minus nullity of T is 2. So the rank of T is going to be 5. That one we have. Now the rank of T square will be less than or equal to minimum of rank of T is 5, comma 5, less than or equal to 5 plus 5 minus n. What is n? N is the dimension of R7. It is 7. So 10 minus 7 is 3, less than or equal to rank of t square, less than or equal to minimum of 5, that is 5. So this is the inequality we need. And what is the problem asking? It's asking then the minimum possible value of rank of t square. What is the minimum possible value? It is 3. So 3 is the answer. Okay. So this inequality helps us for that. This is important. Okay. So moving to the next question. Here we have a matrix M be a 4 by 3 real matrix. Let E1, E2, E3 be the standard basis of R3 and which of the following are true. The standard basis. You need to know what is the standard basis. Standard basis of R3 will be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. This is the standard basis of R3 and the question is which of the following will be true. And it's given the rank of M is 1. So I suggest you to go with an example. Okay. If rank of M is 1 and it is given like it is a 4 by 3 matrix. So let's make a matrix M for the option number A. I'm just making the matrix M as a matrix which is having rank 1. So I'm just choosing it have 4 rows, 3 columns. It's a 4 by 3 matrix. I'm choosing M like this. It have rank 1, right? And then ME1, ME2 will be linearly independent set. The linearly independent set, which means it doesn't have the 0 vector, right? The 0 vector can always spoil the linear independency. Okay, so what we need to prove? It's easy to prove 0 is not here. If 0 is not here, which means it is linearly independent. Or if you want to prove this is linearly dependent, just prove 0 is there. Okay, so the concept is 0 can spoil linear independency of a set. Okay, so we have arbitrarily chosen some M. Now I'm just choosing ME2. Okay, what is ME2? This matrix times our E2. What is E2? It's a second basis. This is E1. This is E2, second element in the basis. So okay, E1, E2, E3. So I'm just multiplying this M with some E2. 1, 0, 0, 1, 0, 0, 1, 0, 0. What is my E2? 0, 1, 0. Correct? This is my E2. Then on multiplying, I will prove that if this is 0, which means the set is linearly dependent. Correct? So on multiplying, you will get definitely this will be 0. Right? Definitely this will be 0 because 0. Why this is 0? Because here in the second column there is no any non-zero elements, but here there is 1. So in the second row and here in the second column there is no any non-zero entries, which means we won't get anything except 0 from here. That is the ME2 will be the 0 matrix. This one is a 0 matrix. If this is a 0 matrix, it is not linearly independent, right? It is not linearly independent, which means this one is false. So if rank of M is 1, so I have made a matrix M with rank 1. Then I just multiplied it with some E2 in order to get a 0 matrix, which means 0 matrix is in this set. That means this set is linearly dependent. Okay. Similarly, for the B, rank of M is 2. rank of M is 2 means here for the okay. So for the rank of M is 2 and M E2, here I am just considering another matrix M that is having that's having one non-zero entry in its third column. Okay, this is my M. Suppose this is my M, and so this is 1. Now I am finding ME2. So here the rank is 2, and then I am multiplying with the E2. Then here also I will get 0 matrix because still there is no one in the second column, right? So definitely I will get a 0 matrix. That means even if the rank of M is 2, then the set ME1, ME2 will be linearly dependent because again ME2 will be some 0, which means this is linearly dependent. So this option is wrong. So the thing is, you have to try with the matrix, the examples of the matrices, and check whether you will get some zeros in the set. If there is 0 in the set, then you are done. Okay. So what about the option number C? If rank of M is 2, then ME1, ME3. How can we formulate a matrix such that you will get some 0 matrix on multiplication? See, let's try like, yeah, here it is ME3. So the third column, just try to make M with the third column having all the 0 elements, right? So 1, 1, 1, 1. So here I am writing 1, 0, 0, 0. And here it will be 0. And this is our M, and I'm just multiplying with E3. What is ME3? 1, 1, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, multiplied by E3. What is E3 here? Look, this is our E3. 0, 0, 1. Still on multiplication, you will get nothing else, the 0 matrix. Which means this is also linearly dependent. Okay. So here, this option is also not correct. And then if the rank of M is 3, if rank of M is 3, which means there will be non-zero elements in first column, second column, and third column itself also. And then if you multiply with E1 or E3, whatever, if you multiply, then you will get some matrix except 0 matrix, correct? So which means there is no 0 matrix in this set. That is, it is a linearly independent set. So option B is the answer. Okay. So this is something about your imagination. You need to think, if this matrix comes, then this thing will happen. And also the concept 0 can, if you don't know this concept, then you can't solve this problem. So you can, a 0 can spoil the linearly independency of a set. Okay. Now next is also okay, a problem with the vector space P2020 is a polynomial with the maximum degree 2020. Okay, the summation I equal to 0 to an 𝐴𝐼𝐿𝐼 such that A is a real number and 0 less than equal to and less than equal to 2020. Okay, and they defined some W. The W be the subspace given by W is equal to summation I equal to 0 to n, where 𝐴𝐼𝐿𝐼 is in P2020, but AI will be 0 for all odd I. Okay, so for A1, A3, whatever the suffix is odd number, it will be 0. Okay, etc. up to A2019, it should be 0. Okay, that's the W. So the P2020, consider this one. Can you tell me what will be the standard basis here? P2020 here, the standard basis will be? The standard basis of P2020 will be the set 1, x, x square, etc. up to x 20, 20. Correct? This will be the basis. Its dimension will be 20, 21, right? So this is the standard basis. Now, what about the W? The W is, it contains the polynomials of the form A0 plus A1x is there? No, A1x is not possible because A1 should be 0 there. So A2x square will be there. Then all the even numbers will be there, right? X to the power of 4, 6, etc. up to A 20, 20, which is an even number. 20, 20 will be there. This will be the W. Then what will be the basis of W? The basis of W will be, here there is a 1, so 1 and this x square, x to the power of 4, x to the power of 6, etc. up to x to the power of 20, 20. These are the bases. So what is the dimension of W? So what is the dimension of a vector space? The dimension of a vector space will be the number of elements in its basis. So you need to count the number of elements in the basis of W to find the dimension of W. So how many elements will be here? From here to here, there will be half of 20, 20 elements, right? Which is 1, 0, 1, 0 from here to here. But there is also 1. So plus 1 will give you 1, 0, 1, 1. So this will be the dimension of W, 1, 0, 1, 1. Okay. So that's it. Now, okay. So the next question is, you have a matrix M. You have a matrix M, and then you need to find out the value of the determinant 8i minus m the whole cube. Okay. The matrix M is given, and you need to find out the determinant of these things. So, you know the determinant of 8i minus m cube will be equal to what? We can just split it, right? Right? 8i minus m, 8i minus m times 8i minus m. Correct? Because we can split the determinant. See. So, you can just find the determinant of 8i minus m, then just multiply. Then you will get the answer. So here, what will be the 8i minus m? 8i means 8000, 0800, 0080, 0008. This is the 8i, then minus our matrix M. Then what you will get? You will get minus 1, minus 2, minus 7, minus 1, 0. Then 8 minus 7, it's a 1, minus 2, minus 1, 0, 0, minus 3, minus 6, 0, 0, 5, and 8. So what is this? This is our 8i minus 1. So the method is you just have to find the determinant of this matrix. Then its cube will be the determinant of this 8i minus m cube. Okay. So what will be the determinant of this? It is minus 1 times the determinant of this one. So 1 minus 2 minus 1, 0 minus 3 minus 6, 0, 5, 8. Because these three elements are 0, so we don't need to calculate that one. So here it will be minus 1. Then similarly here, these two elements are 0, so you need to focus on only this one times this one. So 1 times minus 24 plus 30. So you will get the answer 6 minus 6. Okay, so minus 6 will be the determinant of 8i minus 1 m. Correct? So this is the determinant of 8i minus m. And the problem is you need to find out the determinant of 8i minus m cube, which means minus 6 cube, that is, the answer will be minus 216. So the answer will be minus 216. So this will be the solution. Okay, so that is the answer. And thank you. I'm done. I hope you understand all the problems, or do you have any doubt?
Thank you. Thank you, Shahana.
Thank you so much.
With a good collection of previous year questions. Okay, dear friends, now it is your time to share the feedback. So feel free to share your feedback, and also you can ask any of your doubts, if any.
The class was really nice. Ma'am, you started from the basic questions. You didn't go to first complex question. Ma'am, that was really nice. You explained it very calm and sweetly, ma'am. That was also, you learned a lot, ma'am. Thank you so much, ma'am.
Thank you so much. Thank you, Archana.
Sir, today, like, I really liked the class today. I completed a lot of topics in linear algebra. And when I was doing the previous year questions, I had some confusions regarding some questions. And I saw those questions here today. So, like, when I saw the questions, I realized what topics had I missed. Like the in one question you used that the zero spoils the linear independence. Like that concept was new for me. Like similarly, some questions which I had doubt, that was discussed today, and so, like, I can say that I understood all the topics which were covered, all the questions I understood today. So thank you, ma'am, for the class. Thank you, sir, for arranging this class. Thanks a lot.
Thank you. Thank you, Gopika.
Hello, sir. Am I audible?
Yes.
Ma'am, today's class was very informative. I could note down whatever was important. Today's class was like a perfect paced for me. All the questions were of a very decent level. Some of them were IIT JAM questions and all. So today's session was very much worth it. So thank you, ma'am, for the efforts.
Thank you. Thank you, Praveen.
Dipti Pandey, you can speak now.
Good afternoon, sir, and good afternoon, ma'am. So thank you for this nice session. You are you explained the questions in the easiest way possible. Like, we may think it in a complicated way. Actually, when I saw some questions, I was like, I felt like in the way it was much more complicated. But when you explained it, I thought like, oh, there was some other easy method for this. So thank you for this valuable session. It means a lot. Thank you, sir, for arranging this.
Okay, thank you, Isha.
Hi, ma'am. I'm Shyama. I really liked today's session. It was very nice and it was easy to follow. I got disconnected a few times due to network issues, but I was able to follow most of the session. Thank you so much, ma'am.
Thank you. Thank you, Shyama.
Dear participants, if any of you would like to share a feedback, you can make it now. Some of them are sharing their feedback in the chat box.
Yeah. Thank you.
Okay, for the participants, let me ask one question. Could you share some details about the admission for PhD process in your university, namely Khalifa University?
Now I need to share it?
Yeah, if it's possible, you can at least the outline.
Yeah, actually here in the Khalifa University, there is a direct PhD option. I think I didn't notice in any other universities. Like, after your bachelor's, you can directly apply for the PhD here. So I think that's a wonderful opportunity for everyone. And the other thing is after the master's. And anyway, the eligibility criteria includes like, in the bachelor's, you should have an at least 3.5 CGPA out of 4. And for the masters, you should have 3.25 out of 4 to get the admission here. And the other eligibilities are IELTS. You should have at least a 6.5 overall band in IELTS exam. And also another one more exam is there. I forgot its name. Okay, anyway, I will try to share it with Dr. Vinod Kumar, sir. Then those 2 exams are really important for the admission. And then if you have any other add-ons like net exam qualification, or you have some paper publications, or you have participated in some international conferences, that's really an add-on. So accept the minimum eligibility. If you have something extra, that will help you for getting in the university. And here they are providing a scholarship. It's based on 3 different tiers. You will get admitted in a tier 1. You will have full fee waiver. You don't have to pay anything for studying here, and you will get monthly stipend of around 20,000 dirham. That's nearly 4 lakhs Indian rupees a monthly stipend you will get if you are in the first tier. And if it's in second tier also complete fee waiver, but I think the stipend amount is little bit low. And in the third tier, you need to pay 50% fee, like that. That's why there is about 4 tiers of admission. And if you are interested, I think I really advise you to try to get an admission here. It will be a really different experience to studying in an international university. That's it.
Yeah, Shahana, I request you to share the admission details and notifications whenever it appears. Please share with our group so that our members can also apply there.
Sure, I will share it with you.
So thank you, Shahana, for today's session, and also I hope that you will do more such sessions in our platform. I know that you are very busy with your research and PhD. Yeah, even though whenever you get time, please do help us by handling this type of sessions. Actually, this type of sessions are very much helpful for our juniors. So I request your support in future too.
Yeah, sure, doctor. I will do my best.
Okay, thank you, and all the very best for your PhD. Thank you, Shahana.
Thank you so much. Thank you everyone for joining.
Yeah, thank you everyone. Bye.